Hey everyone, and welcome to The Explainer. Today we're on a bit of a mission to completely demystify HMI design. Look, if you've ever felt intimidated by industrial automation, or maybe you're an engineer looking to really sharpen up your interface skills, you are absolutely in the right place. We're going to break down these complex automation concepts and make them not just accessible, but honestly, genuinely fascinating. By the end of this, I promise you'll see operator screens in a whole new light.
All right, let's dive right into this. We've got a solid roadmap for today. We'll kick things off with the value of good design, peek under the hood at how HMI systems actually work, run through 10 essential best practices, explore the real-world industrial benefits, and then finally, we'll take a look at Devi automation solutions. So starting with Section 1, the value of good design, usability over decoration.
Now, design in this context is a critical business tool. It's definitely not just an art project. I want you to picture something for a second. Have you ever been stuck using a totally confusing HMI, or human-machine interface screen? Picture yourself standing out there on a loud, chaotic factory floor. You need to stop a process, and you need to do it right now. But the screen staring back at you is this cluttered, frustrating mess of flashing colors and tiny text that looks like it was built back on Windows 95. The stakes here are incredibly high, you know? A poorly designed interface doesn't just look ugly, it actively slows down production, causes operator errors, and fundamentally compromises workplace safety.
To really put this into perspective, let's think about a water pumping system. A bad interface for this is usually packed with way too many bright colors, tiny text you can barely read, and buttons that just don't logically make sense. Now contrast that with a genuinely good design. We're talking a clean layout, large, easily clickable buttons, crisp labels, and color-coded alarms. It is literally night and day. Because of that good design, an operator can work significantly faster, make far fewer mistakes, and instantly understand exactly what the machine is doing.
Let's keep moving. Section 2. How HMI systems work. The data journey.
So, now that we know what a good screen should feel like, we need to understand how it actually functions under the hood. This entire data journey is a continuous, real-time feedback loop. It all kicks off at the physical level. Sensors collect raw data straight from the machine. That data is then fired over to the PLC, the Programmable Logic Controller, which basically acts as the brain, processing all those inputs. The PLC then feeds this processed data right up into the HMI, which displays the real-time status to the operator. The operator reads it, makes a decision, interacts with the interface, and sends a command right back down the chain. The PLC receives that command and physically controls the machine. It's this seamless, non-stop flow of data bridging the gap between human intent and mechanical action.
All right, Section 3. 10 Design Best Practices. The core solution.
These guidelines are honestly the secret sauce for building interfaces that are clear, safe, and efficient. Now, what's really interesting here is how simple but incredibly powerful color is in design. Using consistent, standard color conventions acts as an instant visual language for operators across literally any facility. Green means running, red screams alarm or fault, yellow gives a warning, blue provides information, and gray just tells you something is inactive. An operator shouldn't have to read a whole paragraph to figure out a machine is failing, right? A quick flash of red communicates the entire problem in milliseconds. Beyond just colors, the rest of these top 10 practices are really all about absolute clarity and efficiency. You've got to keep the layout simple. Clutter is your enemy here. Make critical info highly visible and use large readable text so operators can actually see it from a distance. You also want to group related controls together so navigating feels intuitive, and deliberately minimize how many button presses it takes to get a job done. Of course, always display real-time data, but pair it with really effective alarm screens and trend graphs. That way, operators can look at historical data and spot process changes long before they turn into catastrophic failures. And this is absolutely crucial. Restrict access. Implement user security to lock down those important settings using specific user roles and passwords. So how exactly do those abstract practices translate into physical components? Well, a professional HMI really needs a few non-negotiables. It must have a clear header showing the machine name, date, and time. It needs a completely intuitive navigation menu, a high-level process overview, and very distinct start, stop, and reset controls. You absolutely must include status and emergency indicators, along with a dedicated space just for alarm messages. And finally, having trend graphs, data entry fields, and production counters gives operators the context they actually need to manage the process, rather than just reacting to it. Every single item serves a deliberate, easy-to-understand purpose.
Which brings us to Section 4,
Real-world industrial benefits, the transformation. Let's take these rules and see the actual tangible ROI they create out on the factory floor. Think about a real use case from a packing plant, because this brilliantly illustrates the power of design. Before their redesign, the original HMI used these overly bright backgrounds, tiny buttons, and wildly confusing navigation. The result? Total chaos, honestly. Operators were frequently selecting the wrong settings, which caused massive production delays. But then, they applied the exact best practices we've been talking about. After the redesign, the interface had larger buttons, simplified navigation, really clear alarms, and standard colors. The transformation was immediate. Operator errors completely plummeted, troubleshooting got so much faster, and overall production efficiency just spiked. Good design literally saved them time and money. And honestly, that packaging plant is just one single example. The sweeping advantages of well-designed HMIs impact almost every modern industry you can think of, from food processing and pharmaceuticals to oil and gas, power generation, and even smart agriculture. We are talking about vastly easier machine operation, much faster troubleshooting, and a massive, massive upgrade in operator safety. Because the interface is actually intuitive, you heavily reduce human error and drastically shorten the training time for any new hires. Better interfaces simply lead to better decision-making on the floor, which ultimately guarantees higher equipment availability.
Finally, Section 5, Devi Automation Solutions, your engineering partner.
Look, understanding these concepts is a great first step, but finding the right partner to actually implement these advanced Industry 4.0 systems, that's the real game changer. Devi Automation Solutions provides complete, end-to-end engineering solutions. They don't just stop at HMI development. Their expertise spans PLC programming, SCADA systems, VFD drives, and they even integrate cutting-edge artificial intelligence and industrial IoT into facilities. Whether you are working in heavy industrial automation, smart agriculture, or looking for solar solutions, they are the comprehensive experts who can build these smarter automation systems from the ground up.
To wrap up everything we've covered today, I really want to leave you with this core thought. By following these best practices, engineers can create reliable HMI systems that improve productivity and support Industry 4.0 initiatives. Simple, well-organized interfaces are no longer just a nice-to-have feature, they are an absolute, vital necessity for modern automation. They empower operators to monitor processes seamlessly, respond to alarms instantly, and seriously slash down time.
So, as we bring this explainer to a close, I want you to think about the systems you interact with every day, or the facilities you help run. With the tools and best practices we've explored today, I have to ask, how will you design the smarter interface of tomorrow? Thank you so much for hanging out and learning about this with me. Keep observing, keep improving, and I'll catch you in the next one.